Hi and welcome back to maths class. Today we're looking at continuity and we're answering the question, how do we know if a function is continuous? So I've got three criteria written down there for you, and the first is f of x is continuous at the point x equals a if f of a exists, if the limit as x approaches a of f of x exists, and if that limit equals f of a. And we're going to look at some graphs in order to determine what that means. Now, this is the formal definition of continuity, but I'm going to talk through an informal way of looking at a graph and determining whether it's continuous as well. So first of all, just a reminder that this second point, the limit as x approaches a of f of x, exists if the limit from the left equals the limit from the right. So as long as we can see that the limit, and we can look at the graph to observe that, from the left equals the limit from the right, then the limit exists. So I'm going to look at continuity from the perspective of looking for some examples that are not continuous. Here's my first example. I call this one a hole. If there's a hole in your graph, then it is discontinuous. At x equals a here, let's look at our three criteria. Does f of a exist? No, it doesn't. When x equals a, there's a hole in my graph. So my first point does not hold. So it doesn't matter that the limit exists, because if I look at this graph, I can clearly see that the value of y as I approach from the left equals the value of y as I approach from the right, which means that the limit as x approaches a of f of x does exist. But that doesn't mean the graph is continuous. F of a itself does not exist. There's a hole there, so the function is not continuous. The other way of looking at this is if I were traveling along this and it's a road, right? Do I need to leave the page? My finger is traveling along, I get to this hole, I have to do a little jump to get over it. So I can't draw that without lifting my pen off the page. The rest of it is continuous. It's only at this point here that the graph is discontinuous. All right, that's a hole. My second kind of discontinuity is a jump. All right, so let's look at the three criteria. Does f of a exist? When x equals a, I can clearly see here that there is a value for the function right here. That's a colored in dot, which means that this point is included. So there's no gap in my domain here. As I move along, there is an x value for all of these points accounted for on the graph. So what about the limit as x approaches a of f of x? Does that exist? Well, as I approach a from the left, I am approaching this value of f of x. In fact, this value here is f of a. But as I approach a from the right, I'm approaching a different y value up here, which means that the limit from the left is not giving me the same answer as the limit from the right, which means the limit does not exist. All right, this limit does not exist, therefore this graph is not continuous. And once again, the other way I can determine that is simply by following the graph with my finger, and look, I need to take my finger off to get from here to here, therefore the graph is not continuous. Now here's another kind of jump, but the criteria are slightly different. If I look at the first criteria, does f of a exist? Yes, it does. It's right there. There is a value for f of x when x equals a. Does the limit as x approaches a of f of x exist? Well, if I approach from the left and if I approach from the right, I am approaching the same point, which means I'm approaching the same y value. So yes, the limit exists. So now I need to go to my third criterion. The limit as x approaches a of f of x equals f of a. Well, that's not true. The limit of f of as x approaches a of f of x is going to be this value down here, whereas f of a itself is a different value up here. And once again, if I wanted to draw this graph, following on x from starting at the left and continuing on to the right, I head towards A. At A, I need to jump up there and put a point and then jump back down. So my finger has to come off, or my pen would have to come off in order to draw that. So that is not a continuous graph. My final example is an asymptote. Now, in this graph that I've drawn here, I have an asymptote at x equals a. So let's look at my criteria. Does f of a exist? No, it doesn't. When x equals a, there is no function. There is no f of x when x equals a. I've got an asymptote. So therefore, this is not a continuous function. And in fact, in this particular graph, if I were to explore it further, the limit as x approaches a from the left of f of a is different than as I approach from the right. So the limit also does not exist. But I didn't need to do that. I've gotten to there, and that tells me everything I need to know. Let's look at our informal way of thinking about it. If I draw this graph, I continue up through there, then I need to take my pen off the page and start drawing down here. Because I had to take my pen off the page to draw this, the graph is not continuous. And that's our summary of continuity.